quiz tomorrow. You got reflections. Any line. Any line. Horizontal, vertical. Y equals X. Do you remember the rule? Y equals negative X. Do you remember the rule? And then be prepared, reflecting over just a random line like that. Okay? We went over one in class. We went over one in homework. It's tedious. All right? It's tedious. We don't have the time to go over it. All right? You got to make sure you find the equation of like A prime, see where the two lines intersect, do the skip method. I'll be here after school, all after school today. If you want to sit down, we can make up a couple problems, see how you do. Also be prepared if I say A is 2, 1. Sorry, A prime 2, 1. A is negative 3, 6. What's the line of reflection? So find the midpoint. Slope, negative reciprocal. Write the equation of the line. Okay? That's all reflections. I just want to make sure you are fully aware of what's coming at you tomorrow. All right, that's all reflections. You have translations tomorrow as well. Translations. Make sure you are very aware of all three notations. Anybody remember this notation? It's a translation, but it's a function notation. And then you have this. That's vector notation. And then you have the other notation, which is the capital T. All three represent a translation. And yes, I will ask in specific problems, leave your answer in function or vector notation. I will ask that on a couple problems. Leave it in a specific notation. That's translations. Also, I know this every year this happens, so I'll warn you before you take the quiz tomorrow. If I give you, say I give you a figure on a graph and I say, what's the translation rule? Make sure left and right is the X coordinate, up and down is the Y coordinate. Okay, because kids will automatically I guess it's something in the mind, automatically go up and they'll write that number first. Okay, when you go up, that's the Y coordinate, not the X coordinate. All right, so keep that in mind tomorrow. And then you have rotations, 90, 180, 270 from yesterday. Or negative 90, negative 180, negative 270 from yesterday. Constructions, there's only two I could give you tomorrow. There's only two. Reflection, translation. So reflection over a line, can you do that construction? And translate given a vector. We've gone over another one, which is find the line of reflection, but I'm not going to give you that tomorrow. It's going to be one of these two. There's one on there. So be prepared for both. Okay? The videos, as you know, the step-by-step videos are up on Aspen under your transformation folder. So that's what you're looking at tomorrow. Questions there for tomorrow? What we do today, it's going to be a little more honors level rotations. I didn't put on there. There are no constructions involving rotations because we haven't done them yet. Anything you want to ask about tomorrow? Going? Yes, Meg. Via construction? No. Via algebraically? Possibly. Yep. Anything else? Any other questions? Okay, can we first take care of your Regents questions? Can we first take care of those for me? Okay, here we go. Let's first do question number 1. And again, answers are great, but I'm going to have to ask you some background on how you got it. All right, here we go. Problem number 1. Come on up. 25. Come on up. Problem number 1. I handed these out yesterday. If you don't have one, I believe they're over on the desk right over against the wall. Okay. EFG, AEG 137. So you found that. What's EGF 105? Okay. Anybody questions there? Found the supplementary angle, right? EFG 32, AEG was 137. What's EGF? All right. It's fine with me. Anybody use alternate interior angles because the lines were parallel or no? You could do it that way too. All right, you could do it that way. If that one, remember, if this one's 43 right here, so is this angle right here, that's 43. If that's 32, that's 32 as well, and all three angles add up to 180, so another way of doing it. All right, thanks, Allie. Nice job. You're actually, funny coincidence here, you're going to see this question again today in your notes, so that'll be an easy one to do it when we get to that point. 22? Okay. Yeah, let's go. What do you know about a translation and a reflection? Doesn't change size or shape, so that's what makes them congruent. Why are they still similar, though? Because aren't similar triangles, their sides are in a ratio? So do those triangles. But they're not congruent. I know that. That's why they make them congruent. Now I'm asking you why they're similar then. What about the sides? Okay. What I'm trying to get at here is if two triangles are congruent, they are also similar. Because the corresponding sides are in the same ratio, right? What is that ratio for two congruent triangles? 1 to 1. Okay, so that's why two congruent triangles are always similar. Everyone all good? Okay, here we go. Homework. Anything you want to ask on the homework? You had to graph 3 of them, I believe. If you want to ask about that weather vane question, rotating at 270, go ahead. I have 39 and 40 up here as well if you want to ask those. I'm just still a little nervous about you rotating in the right direction, but hopefully you got plenty of practice with that last night. Anything we want to ask about? You want to see? Grace? Which one? 39. All right, I'm taking this point right here. I'm taking this trapezoid, and I want to know what is the image with point R prime at 4, 3? What rotation of the trapezoid creates an image with point R prime at 4, 3? So I need point R. I need to do one of these to get to 4, 3. We good? So I'm either going to turn this 270 degrees. I'm either going to turn it, probably not 185. I'm going to turn it 180, or I'm going to turn it 90, and I'm going to end up with R being at 4, 3. Okay, ready? So I'm actually going to physically rotate this now. Actually, just get this. Okay, here we go. I'm going to rotate this bad boy. What's my first option? Rotate it 270 counterclockwise or, around point. Okay, no, I can't rotate it. Never mind. Because if I, just so you know, I think I talked about, actually, we'll talk about a little bit about it today. If you guys do the whole turn your paper method, that's only centered around the origin. All right, so just make sure you're aware of that. This isn't centered around the origin, so I can't do that. It's actually centered around, anybody see point T? Okay, so point T is going to stay where it is. If I go 270 counterclockwise is the same as what clockwise? 90 degrees clockwise. Okay, so right now, this point right now is at 1, 2, 3, 1, 2, 3, 4, negative 3, 4. Okay, so if I rotate it around point T clockwise 90 degrees, it is going to go into quadrant 1, but I don't believe it's going to go to 4, 3 though. It's going to go to, should go to 3, 4. If you wrote, because point T is going to stay right where it is, so I'm going to rotate this around here, but it won't go to 4, 3. Yeah, we're good. All right, we're coming up here on the answer. You good there, Grace? 180 is just on the opposite side, so that's going to be in quadrant 4. And there's no way I'm going to get 4, 3 in quadrant 4 when it's in quadrant 1. Good so far? 185, no shot. And then now 90 degrees clockwise about the origin. All right, now I can rotate this bad boy. Nice. Let me go back to the beginning one. Okay, here's my beginning one. 90 degrees clockwise. Ready? 1/4 turn to the right, right? Now where's R? 1, 2, 3, 4. 1, 2, 3. Now it's at 4, 3, which is what the problem was asking me at 4, 3. Okay. Yes. It won't. Nope. You'll be able to turn your paper or memorize the rules I gave you yesterday. Anything else? Going? All right, let me see it in your graphs, and then we'll get set up for today's honors rotations. Degree measure, but we're not going to go on the graph either. All right, we're not going to stay on the graph. We're going to go to these actual polygons to start rotating around. So pretty clever of me, I know. I have regular pentagon penta, and it's divided up into 5 congruent triangles. Everyone see where point E is? I want a 72, yes, 72 degree rotation around point X. No quarter turn, so don't even think about turning your paper. Oh, I think this is about 72. No, it's not. All right, around point X. Well, first, 72. We going clockwise or counterclockwise? Positive 72. We're going counterclockwise. But how can I find 72 degrees? Well, we know all these triangles are congruent, so aren't all these angles right here congruent? Yeah, can you find me one angle measure right there? Because that'll be, like if I go from E to P, that's the same angle measurement from going here to here. All 5 are congruent. What should they add up to? 360. Yeah, so let's take a little quick calculations here. 360 divided by how many angles are there? 5. So it looks like every time I go vertice to vertice, I'm going, whoa, 72 degrees. So I'm at point E here. And we already know I'm going 72 degrees every time. So what vertice do I end up if I go 1 turn counterclockwise? E moves to? E will move to? P. Take a look. You just found this is 72. 72 degrees. So I am going to end up at vertice P. All right, now I want to go from P, the image of P, 216 degrees. 216. Is there any relationship between the 216 and the 72 that we just found when you go once? It's going to be 3 rotations now, but now going from P in a counterclockwise direction. So if we're at P, we go 3 rotations. I end up at 27. Where do I end up? N. 1, 2, 3. I end up at point N. All right, questions from you guys? All right, let's try this one more time, but with a different figure, an octagon. 8's up. 8 congruent triangles. So right now, let's first, before we even get into 1 through 6, when I go from vertice to vertice, how many degrees am I rotating from vertice to vertice? I should end up at 45 degrees every time I rotate vertice to vertice. All right, so 45-degree rotation of G. I'm just going to start asking everybody here. Here we go, 25. Where do I end up? J. Is that a J? 8's up. There's no J in 8's up. How about an I? One job, Allie. Okay, 225 from point U. 225 from point U. 30 when you're ready. I as well. 315 from point E. 315 from point E. 30. Oh, 3 I's in a row. Let's keep this streak going. Probably not, considering now I'm rotating a segment. So if you give me I don't think that's appropriate. I need a segment back. If you rotate segment EI 270 degrees, what segment do we end up at? When you're ready, 12. What is it? IG? 270? How many, ready? How many times you're rotating? From EI, right? So 1, 2, 3, 4, 5, 6. GH. Don't get rattled on me, child. Don't get rattled. HG. 135 of point S. 10. G. And another rotation. Oh boy. Who am I going to get on this one? 360-degree rotation of ST. 13. It would be ST. Look at you. That was tough. Questions? We okay there? Finding the degree measure and then rotating appropriately. All right. Everyone all right? And let's not bring our classmates down like that, please. Yeah. All right, here we go. I got an equilateral triangle. Rotated clockwise around its center. What's the minimum number of degrees it must be rotated to carry it onto itself? Well, first of all, we got to, what do I mean by carry it onto itself? Any ideas before we get a good definition here? What's up, Meg? Well, I don't want 360. That would be 360, right? I want the minimum. 360 would be correct, but I'm looking for the minimum number. There's actually a smaller amount of degrees. Carry it onto itself gets me another equilateral triangle. All right, gets me another. So same. Here's carried onto itself. Same shape. Same size. Now, many of you may be saying to yourself, well, same shape, same size. I can do 1 degree and it's still the same shape, same size. Same position. So I need to rotate this however many degrees. Hey, and I get that bad boy back right there. And it's not 360. There's smaller degree measure. I could turn this. You have to rotate it, wise guy. All right? Smaller than 360. That I still get that triangle back. Watch, ready? Here you go. This is what I'm talking about. Little visualization here for you. Oh, I didn't even want that to happen too. God, I knew I should have just went to the blank one. Ah! Just took all my mojo too out of turning that thing. You know what? That's how confident I am. I'll give you a slide left or right if you want that one. All right. Yeah, that's right. I'm going big dog here. Any others before we get going and voting? Curtains. Shatter. Fade. Cubes. Genie. Curl. Slide either way. Okay. I don't even think I have to. Okay, here we go. Promethean manner or slide either way. Hopefully I don't regret this decision. Here we go. The old genie. Sorry, everybody. The old genie nobody voted for. Okay, here you go. Here's what I'm talking about. Ready? Here you go. This is what I'm talking about. Everyone, ready? Tell me when you see that triangle back. Okay, how many degrees did I go? Because obviously it wasn't 360. How do I figure out how many degrees I went? Well, what did I just do? Really, what I just did by rotating it, I went from this vertex to that vertex. Correct? How many times would I have to turn it to get back to the original one? 3 times, right? 1, 2, 3, and I go a total of how many degrees? 360 divided by 3 turns gives me 120. That's what it would take. 120 degrees. What if I asked you for a square? So that would be how many degrees? 90 degrees. Okay, 90 degrees to get a square back. All right, we all good there? Okay, moving on. All right, now we've rotated points. That's it, just points. What about a line? Can we rotate a line here in an honors level class? You're darn right we can. I'm going to take this line, 2x plus y equals 1, and rotate it 90 degrees. Rotate it 90 degrees. What's the equation of the new line? Hey, what's the line made up of? A bunch of points. So why don't I just take those points on the line and rotate it 90 degrees and see what the equation of the new one is. All right. Let's just take a look what this line looks like first before we rotate it. 2x plus y equal to 1. Anybody want to get that in y equals form real quick? Y equals negative 2x plus 1. What's the y-intercept? 1. And then how can I graph a couple more points here? Down 2 over 1, down 2 over 1, or up 2, left 1. So I want to turn this 90 degrees. It's positive 90, so which direction? Counterclockwise. 90 degrees. 90. What do I keep emphasizing that? It's going to form a right angle. So what am I trying to get you guys to focus on here? Perpendicular. Keep going. Slope of this line? No. This line right here, the one we were given. -2. What's the slope of my rotated line? 1/2. So I know the slope of my rotated line is 1/2. How do I find the y-intercept? Usually think. Usually we do y equals mx plus b, right? Where can I get a y and an x coordinate on that line? What are all these made up of? Points. Take a point. That's not the point I want to plug in, though. I want to plug in a point that's been rotated 90. So let's take, ready, everyone? Let's just make a class decision. Let's take this point right now. Everyone ready? Rotate it 90, counterclockwise. Counterclockwise. What's that point now after I rotate it? It's -1, 0. And again, I could have done that with any point on this line. I just chose that one because I thought it was the easiest and quickest. Now let's find the y-intercept. 0 equals, what's the slope of this rotated line? 1/2 times -1 plus b. What is our b value? B value is positive 1/2. Okay, I'm going to need somebody right now to put it all together. And what's the equation of the line? Of my rotated line. 10. What do you got for me? Y equals. There we go. Okay, everyone all right how we did that? And that's not even the only way. This is the great thing about it. Let's say you didn't even think about doing negative reciprocals. Could you have found 2 points, rotated them, jotted down those 2 points? So here you go. Ready? You would have had, what was our 1 point we had? -1, 0. Do me a favor right now. Somebody rotate that point right there. What's that point rotated 90 degrees? 1, 1. Could you have come up with the equation given these 2 points? Slope. Find the slope. Change in y over change in x. Took one of them, plugged it into y equals mx plus b, and found the y-intercept. So a couple different ways. Get 2 points off and write the equation, or do the negative reciprocal. Questions there? All right, we don't have to spend any time on number 4 because we answered that about 20 minutes ago. Congruent and similar as we talked about earlier. All right, couple more Regents level questions. I believe this is a question coming up later on in the week on your region. This is in your own Regents packet. Regular hexagon. Triangle ABG is reflected over BG and then rotated 180. If you want to try that on your own, discuss it. So reflect it over BG. It becomes a new triangle. Rotate it 180. It becomes a new triangle. Five, new triangle you ended up with. F, E, G, thank you. Choice 1, F, E, G. Hey, ready? Hey. Flipping it over BG, highlight, goes to BGC, rotating it 180, Yes, I do end up at FEG. Any issues there? Last one, digging deep. Another one of these carry it onto itself problems. All right. So here's what I'm looking for. I have this rectangle. I have three choices. Which one will not produce this same rectangle? Okay, which one will not produce this same rectangle? Here we go. A reflection over the line y equals x. Good review for tomorrow. What do I do with my coordinates for y equals x? Flip them. Everyone ready? 7, 1 for point A would become what? Oh, and what do you notice about 1, 7? Oh, it's a point on the rectangle. 9, 3. 3, 9. Does everyone see every time I flip them, I get the same point on the rectangle? So that's going to carry it onto itself. I'm looking for the one that does not. Ooh, negative x plus 10. What's that line look like? Well, what's the y-intercept? What's the y-intercept? 10, ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's the slope? Negative 1, so I can go down 1 over 1, down 1 over 1, down 1. Everyone's starting to see this line here? What do you think there? If I take A and reflect it over that line, where's it going to end up? B. If I take C, it's going to end up at D. So am I changing the size, shape, or position of this rectangle? Absolutely not. All right. We'll get there sooner or later, right? Next up, a rotation of 180. So directly on the other side, around 0.66. Everyone find 0.66. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 180. There's a problem, I think. Well, everyone agree C and B are just going to flip-flop. 180, they're just going to go on the other side. What's the problem? D and A are not going to flip-flop on each other. D is going to go somewhere over here. 180 is on the direct other side, correct? So D is going to go somewhere over here, and A is going to go somewhere over here. That's not going to map it onto itself. All right? And yes, because we are in the honors level here, I do want to go over why 4 is correct, or 4 would map it onto itself. Find 5, 5, everybody. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Everyone see that? Now, if you moved every point to the other side, it would C would go to A, D would go to B, B would go to D, so they would match up with each other. All good? Okay. Tonight's homework is a lot of review. A lot of review. We got plenty of time. Get a Chromebook out with the answer key here. All right. This is all review for tomorrow's quiz. All right. All review for tomorrow's quiz, which you guys can get started on right now. Yep. What's that? No. Nope. Sure. I'll answer questions first thing tomorrow, and then we'll start.